All right, so we're going to be looking at the runtime of the MergeSort algorithm. Exactly how do we assess what the runtime is, and how we can go about searching that, and what the best ways to do that is. So first of all, runtime, right? Runtime of an algorithm will be represented by Tn. That means it's going to be a function of the input size. It's going to depend on the input size. So if you are dealing with a list of 10,000 inputs, well, that's going to obviously take a lot more time than if there was only 8 inputs like we saw 2 episodes ago. So it's going to be a formula, essentially. We're not going to have a numerical value unless we actually do have a value of n that corresponds to our input size. So how much time would MergeSort take? Well, let's go ahead and write it out again, right? I like to write things out a few times because if you didn't understand them the first time, maybe rewriting it will make things a little bit more clear. So let's go ahead and write out the MergeSort algorithm over here. So MergeSort, and we're going to have our inputs over here, x1, x2, x3, all the way to xn. So that's the list we want to sort. It's unsorted values that are going in over there. And we know right away that if we find the value of n, and remember n corresponds to the number of inputs over here. So if this over here was, let's say 7, that means you would have x1, x2, x3, x4, x5, x6, x7, and those values could be 1, 2, 9, 6,000, 3, 5. They could be any numerical value, right? Those are the ones that need to be sorted. So I'll put that little note here, actually, just in case, we're just still a bit unclear what's going on. This needs to be ordered. Sorted/ordered. I like the word ordered a bit more because it's a bit more clear what it's asking. Sort, it's a bit vague if you don't know the context. So if n is equal to 1, right away we know that if n is equal to 1, we're finished, right? That means that one value standing on its own is going to be sorted. So we will return that value. N is the number of values, x is that value. So if 7 is the one value you have, you will return that value of 7. Now, if we have not satisfied that condition, we will enter this next stage over here, the else, where we will go ahead and we will be returning merge. And this will be merging 2 recursive calls to the MergeSort algorithm. So we'll have MergeSort, and this will be called on the first half, which is x1 all the way to xn over 2. And you'll also have MergeSort xn over 2 plus 1 all the way to xn, right over there. So that'll be the second half. And I'll go ahead and close off that bracket right over there. So we have all this set up over here. What are going to be the runtimes? So we're going to look at this. And I know I'm assuming you guys know some Big O notation. I will have videos on Big O notation, so make sure you check those out. Go ahead and get a new color here. So let's go ahead and break this down one by one, right? There's going to be one step which is going to be essentially in charge of dominating and controlling the runtime of the algorithm. Let's look at this over here, right? Is this really going to have much impact? This over here is going to be running in constant time. And we can think of just that simply as big O to the 1, or big O of 1, right? It's not going to impact anything. There's going to be bigger tasks that are being handled right now. So this part over here, this base case that we will go in if we actually satisfy the condition of having an input of 1, it's not going to impact anything right now. We don't need to worry about that. It is going to be staying away from us. So we go down here to the part where the recursion happens, the magic. I'll move over here so I get a bit more space. Now, what do we have over here? What are these things running in? These 2 recursive calls over here, what are they going to be running in? Well, these are going to be running in Tn over 2, Tn over 2. No, what is that? What is that? Well, the whole MergeSort, this whole thing is going to be running in Tn. n time, right? The time is going to depend on the input. Simple. Whatever that function is, it's going to depend on the input. Well, now we have split the input in half. And we've done that twice. We've split the input in half twice. So naturally, the time is going to have half the input. It's going to still have the same time, which we're going to work on, but it's going to be split in half. So it's just a little way that we're going to be working on to get the information that we want. Now, merge is still going to take some time as well, right? The part of actually putting these together is still going to take some time. So the merge over here, and I'll just scroll up again, that arrow is connected to merge. Merge will also take time. You will do a constant amount of time constant amount of work, I should say, per comparison, right? We can tell based on how big our input is, how many merges we're going to have to do, right? We know what the value is going to be, right? There'll be a certain amount of merges for a certain number of values because you're going to have to split them all up and then merge them back together. So let's go ahead and write this out, right? We have all this information we're given here, which we're going to use to write the big formula. So the big formula is going to be T of n, and this is going to be the runtime of MergeSort. This will be the big runtime of the MergeSort algorithm. Now, what are the big players that we have going on over here? Right, well, look, we can go back up here. The big players here are going to be T n over 2, T n over 2, and whatever merge is going to be. Those are the big players right now, right? The other one that we saw, the little constant time one, we're not going to concern ourselves with that, right? That little one where we go into for our base case, it's just not going to be significant enough to worry about right now. So we have the merge, the Tn over 2, and the Tn over 2. So let's go ahead and write that out. Simple. So the Tn over 2, well, we have two of them. So we can write 2 T n over 2. So whatever that time is, and that looks funny, right? Because to calculate the time of this whole algorithm, we are going to be calculating the time of a sub-algorithm. So that's a little bit strange, but there's a way to do that, and we will do it. So we'll have T n over 2, and then we'll be plus C n. Now what is this? This is going to be, C is going to be some constant, right? And n is going to be your input. So let's go ahead and divide this up, and I'll explain what that means. So this is your solving the sub-problems, I guess is a good way to put it, through recursion. Solving the sub-problems through recursive calls. And like I said, merging them together will take a constant amount of time. Of n. So it's still going to depend on your inputs. Now, this is what we have right here, and this is not very helpful, right? This doesn't seem to give us any information. It seems like we've solved the time by just simply restating a part of that right away. It seems like kind of a cop-out. So we are going to have to go through many runs of this until we see a pattern. And I'm going to do that in the next video, right? I'm sorry I keep breaking this up, but I'm going to make sure that all the videos are connected to each other so you don't fall out of loop. But I know you guys start to get tired after a few minutes, so I want to make sure the videos are split up. So we're going to continue from this exact spot in the next video.